Good morning, everyone. Online participants, are you able to hear, please? So we are just going to start this 5-day course, PV Fuel Cell Microgrid, a Sustainable Energy Solution. So this 5 days program is provided to you. So we will go according to this schedule. Uh, every day slides will be shared. So in fact, we will try to go as per schedule, but you will see that some topic can be little bit extended, some topic can be discussed slight bit faster, but we will try to stick uh, at least our daily schedule. Whatever is planned in every day, we'll try to follow that schedule. But some topic can go a little bit shorter, little bit longer, but we will try to manage accordingly. Just to start with that, so our first session comprising of lecture 1, 2, 3, 4. So here in this we will briefly talk about the some microgrid concept, microgrid architecture in this morning session, and then we will, after the lunch break, we will move to the second half of the topic. So here, let us start. So here, for this session, the contents, what briefly I am going to discuss, little bit about the concept, definitions of microgrid, the elements of a microgrid, microgrid architecture, microgrid control, and some of the microgrid demonstration projects. So that we plan to discuss. So this will be little bit kind of basic stuff which we are going to further discuss in coming of the slides. So here, what is microgrid? In research, you will see that many definitions have been proposed. What is the microgrid? So here some of the definition, what it talks, what is the microgrid. So here microgrid basically is a concept that is a cluster of loads and the generation, small micro source operating as a systems which can provide both power, electricity, and it can have additional function in terms of like heat as well. Then another definition, what it states that microgrid, as you see that as the name indicates, like this small power system, microgrid. So mainly this microgrid will be comprising of these renewable energy sources, which can be photovoltaic systems. Depending upon availability of resources, there can be another renewable energy sources. Here we are talking fuel cell, but depending upon the availability of renewable energy sources, it can be any source. And then, as you know that these renewables, wind, photovoltaic, they are highly intermittent in nature. So to provide the kind of backup, we need to have some kind of storage devices, for example, batteries. And this microgrid, it can be operated in the grid connected mode or it can be isolated. So here, as per this second definition, what you can see that microgrid, like the generation sources in terms of renewables, wind, photovoltaics, small, mini, micro hydro, it can have any source depending upon availability of the natural resources. And then the backup, backup in terms of battery storage system, it can have diesel generator as well. Then of course the load can be classified as the priority, what is the priority of the load. And then of course this microgrid can be connected to the grid or it can be in isolated mode. So this way you will see that several definitions have been proposed in the literature, and this microgrid, where this microgrid will be connected, what voltage level this microgrid will be connected. So this microgrid generally will be connected at the low voltage level. This will be connected at the low voltage level. So here, based on that, it can be classified as that low voltage grid, or it can be connected on the low voltage feeder, or even at a house level. This microgrid again, it can have further little bit sizing. So here you can see that in terms of low voltage grid, you will see obviously that in the picture you can see different kinds of the sources, like you can see wind, photovoltaics, small hydro, in terms of combined heat and power, then your loads, building loads, electric vehicles. So this can represent a low voltage grid. Then it can have that like low voltage feeder, just like say this feeder representing as the microgrid, again comprising of the sources and load. And as you have seen in case of microgrid renewables, the power flow, if it is connected to the grid, power can be drawn from the grid or power can be fed back into the grid through these power electronic converters. So you can see this another representation of microgrid. We have the main grid connected, this our microgrid connected through the point what we call as the point of common coupling. Then we have distributed generation, distributed renewable energy generations. Depending upon availability of the natural resources, it can be in terms of photovoltaic systems, fuel cell, wind power generation, micro hydro, so any type of renewable power generation. Then of course we have the loads, electrical load, and then just to maintain the real power generation and consumption, we have the storage system. Not shown here, we will discuss that in power system we have to maintain balance for the active power and reactive power in real time. So you can have additionally reactive power support device as well. If there is excess generation, even you could have dump loads as well. Okay. So this way your microgrid is comprised of. Okay. So interestingly, this microgrid can be given different names. What we see nowadays is more popular like the microgrid, but you can see that it can have like the hybrid power system. It can be isolated or it can be grid connected. Even you can call the similar name like the distributed generation. So all these names are, you can see, are very commonly and almost interchangeably used. So like say sometimes we get little bit confusion about microgrid, that we may think that whether the microgrid, generally we call that it would be isolated. So the microgrid, it can be connected with the grid, or in the remote area it could be isolated. So there are both will be called as the microgrid. This like the who will be owner of the microgrid sometime, like say the utility who make the microgrid, they will be owner. So there could be like who will be the owner. Then of course we know that this microgrid mainly based on the renewable energy sources, but as we know that renewable energy sources are highly uh, intermittent in nature, like wind and photovoltaic systems, and they are depend upon the nature weather conditions. So lot of uncertainty is there. So how we make the microgrid reliable, sustainable, like by adding the storage system, by having the diversity of the renewable energy sources, because generating the electricity through renewable energy sources, of course it is renewable and sustainable, but it is quite challenging as well because of the uncertainty of the weather conditions, for example. Uh, so, uh, microgrid little bit a challenging task, but as we have seen, and I will show the, its need, that whatever the major issue what we face from the fossil fuel in terms of fuse pollution, and then that pollution is no more affordable. Okay. So because of that reason, we are seeing the some sustainable solutions. Of course, whatever sustainable solution we are seeing, it may not appear to be, very convenient, very user friendly, because in the night there is no sunshine. Okay. So when we have wind power system, there is no wind blowing. Okay. So things are not, appear to be very convenient to use. But whatever the worst issue what we are facing because of the pollution, the issues. So for that, there is no more further options but to move towards the sustainable solutions. And then similar to that, in the literature, one more terms also used called as this virtual power plants. Uh, so here, as I said, these terms little bit used in the literature. So you may need to go a little bit more, deeper understanding. So what this virtual power plant is basically kind of an energy management system, uh, with the aggregating the capacity with the number of DGs. Here DG stand for the distributed generation. So DG, sometimes we also use the DG term for the diesel generator as well. So you have to be careful. You have to define these abbreviated terms how you are using. Then of course with the ESS stand for energy storage systems. And the loads, in the literature sometimes you will see that they use the technical terms like the dispatchable and non-dispatchable, the nature of load, critical loads, non-critical loads. Sometimes we call it like the priority loads, non-priority loads. Okay. So priority loads, for example, like hospital building, so which will be called as the priority loads. There is more priority for that kind of load. Okay. Basically, when we are talking about this microgrid or virtual power plants, so there can be little bit, some difference in the concept in terms of like the geographical area or locality. Microgrid could be, you can say, could be, separated or concise or the concise area, whereas virtual power plant you can have the little bit wider area. Then of course, when we talk about the size of the microgrid, we'll talk and discuss, and as such you will not find like say very strict or hard definition up to what size of the grid you can classify as the microgrid, what size of the power system you can call as the small power system. For example, this one GIAN program was offered on the small hydropower system. So what you can call as the small hydropower system, which could be further classified as the mini or micro hydropower system. Okay. So as such, there is no unique or well established definition. Different countries, they can little bit define their own ways, what they call it like micro or mini, and these definitions are dynamic, keeps on changing as we progress. Okay. So here basically the different you can have the different architecture concept, and as I said, like the different names can also be used. Sometime when we are doing research, we would like to see that names should look very nice or interesting as well. Firstly, we can see that even hybrid power system name being used, because when we are doing research, so the name looking little bit more, name looking nice. This is very important. The giving the proper name, giving the very nice looking name is very important. Okay, even it could be same thing. Previously we used to call like the hybrid power system. Now we call it like microgrid. You saw these terms which we started very common terms like the smart grid. Okay, more or less things are same, but as time passes, we with the same thing we get little bit bored. So we try to give little bit new name as well, so that we feel little bit more interested. And some of these references from where these figures are taken. So as you do research, you can back refer to this literature when you are going for your research. If you are doing in this direction, so you can always refer to some of these key references if want to go more detail in those topics. These microgrid or virtual power plants, they can further classified like this, whether it could be centralized controlled virtual power plants or distributed controlled virtual power plants. As the name indicates, like the control is either centralized or distributed, or you can have fully distributed control virtual power plants. Then as I mentioned, this what will be the different elements of the microgrid. Obviously you will have the generators, So what this microgrid is a small system. So we use the generators, preferably renewable generators, because this is the whole aim of this microgrid. Okay. Uh, so here distributed generation or preferably renewable generators. So the distributed generation, what we can call as the small or distributed generation, uh, as opposed to centralized generation. Again, as such, there is no unique hard and fast definitions, but what you can call this distributed generation, like few megawatts in the range, for example, 10 to 50 megawatt, could be called as the distributed generation. And then when you call about this, like the microgrid, micro turbines, even the size for these could be generally like few hundreds kilowatts. Your microgrid could be in the capacity depending upon the size. It could be 1 megawatt, 500 kilowatt, around that. So as such, there is no well-defined definitions as well. Then talking about the microgrid, when we talk about the distributed generation in terms of renewable generators, mostly we have the photovoltaic systems. Most of the place worldwide we have the sunshine available, and the PV system is most convenient to use. Okay. So generally when we are talking about the microgrid or this distributed generation, photovoltaic system is mostly there. Okay. Then we see what additional renewable sources it could be available. If there is like say wind, by the way, or by the way any micro hydro, biogas, so it could have any type of renewable generation. Then when we are adding the different renewable energy sources, we are diversifying, and thereby we are increasing the reliability of the system. How we are increasing the reliability? Because sometimes say sunshine in the night, there is no sunshine. Okay, maybe at that time you have the wind. Okay, so by having the diversity of the generation, we are increasing the availability or reliability of the source. Okay. Still, whatever microgrid we have, if we are not able to meet the demand, maybe it could be isolated microgrid. So in that case, we need to have some kind of backup generation. Okay. Backup generation, it could be in terms of energy storage devices, but backup could be in terms of diesel generator as well. Diesel generator again have so many issues. Again, being this based on fossil fuel diesel, causing a lot of emissions, so it is not the preferred one. But still we are bound to use. Okay. In the morning session address, this point was very well stressed by director as well. So but we need to have the backup, then energy storage systems. So with the energy storage devices, we have got wide variety of options about these storage systems. So here energy storage systems obviously offer the kind of backup, so they improve the reliability of the system, and they can improve the efficiency of the system. They can you know, operate the system more smoothly. So here with the storage system, in abbreviated terms, we call it ESS, energy storage systems. So we have the wide variety of options for the storage system. The most, you know, commonly used, most preferred, most convenient to be used is the batteries. Okay, and then we can have the other types of storage systems in terms of flywheels, in terms of capacitor banks. We further call it like the supercapacitors. In mechanical systems, we can have like the compressed air. Compressed air can also act as the storage system. Then very popular type of energy storage system which we use in the electrical power systems in the bulk quantity is called as the pumped hydro storage systems. So this way we have got the wide variety of options for the storage system. Which one will be used in which particular options? So there will be variety of regions which could be an appropriate solution. As I give example, batteries, you will see in the batteries there are, you know, wide range and options available. Okay, so there has to be proper way of thinking that which could be the optimum selection of the batteries. Okay, so as I said, batteries are kind of units and convenient to use. Of course, there are some issues with the batteries as well. Batteries provide the, you know, again you have to see what particular applications for the you know, applications, the backup you need for how much duration. Okay, so the battery can provide the, you know, significant storage time. Battery can use for say few hours, several hours. So depending upon what particular application you need, so you can have the different options with the batteries in terms of like the lead acid batteries, sodium sulfur batteries. So in batteries you'll find like the 5-7 different options. Okay. Then in the batteries, again, what particular type of battery you select for particular application, it will depend upon several technical and economical considerations. Technical means that the charging and discharging rate, even it could have like the how much will be the weight for batteries, how much is the cost for the batteries. So for selection of batteries and what particular applications. So this way there will be number of technical and economical points that has to be considered in selection of the batteries. So these topics here I am just giving you very brief, and this topic you may see that again comes again during the discussion of other lectures as well. Okay. So now, you know, when we are talking about the electrical power systems, so battery itself has become one of the great aspects for the research. What is the size of the battery? Okay. Initially we talked about the, you know, very small size of battery, and now like say battery of what size it can be used in the application of the renewable power system or even in the conventional power system. Okay. Now, for example, if you need the power, okay, say 1 megawatt power we need, for example, which we have to burn the coal and use the electricity. Okay. So can we think of that we can have 1 megawatt battery as well? Okay. So the size of the battery, the size of the battery is quite expanding. So because now this battery has got a great applications, particularly in the renewable power systems, uh, electric vehicles, even in the conventional power system as well. So battery size, battery technology is going to be significantly uh, increased. So this battery showing the picture, for example, is the size of the 100 kilowatt. So now we are started talking about the battery size, not like say very small size battery, but battery here is showing like a sort of like the small size microgrid as well. So battery sizes are really increasing. When we talked about uh, the these different energy storage systems, so here in this slide you can see the different options for the uh, energy storage technology, which you can see in terms of like the mechanical system. In mechanical system, you can have like the pump, hydro storage, compressed air, compressed energy storage, flywheel. Then you can have electromechanical, mainly these batteries, lead acid batteries, and then nickel cadmium. So you can have many options for these batteries. Chemical, uh, electrolyzer or fuel cell. So fuel cell is the part of discussion for this course as well. Thermal energy storage, air conditioning, thermal energy storage. Then in terms of electrical storage, capacitor banks, uh, superconducting magnetic energy storage, supercapacitors. So you can see that there will be large number of options available for the storage system. So which particular type of application to be used? It is not only this like the electrical systems, but you can have some other systems like mechanical systems, where we may prefer to use the compressed energy. Okay. So what particular application you have, how much, so we have got the large number of options for the storage system. I will not go into the detail. Some of these references are provided. One of these is the flywheel. As you will see that a kind of rotating wheel is there, which continuously keeps on rotating. It, as we see that when we have the rotating wheel, it will store the energy in terms of half mv square. Okay. And so it will store the energy, and when the energy is needed, so this flywheel will discharge the energy. So the duration, how much duration this energy is needed, even sometime in the mechanical system, flywheel could be an appropriate option. Okay. So this is like one of the example. Then talking about the loads, loads can be like, our priority loads, non-priority loads, what we call as the critical loads, or non-critical loads like the normal residential buildings, or for example hospitals or some other priority loads. So priority has to be decided accordingly. This If there are critical loads, so which will be given obviously the higher priority, and of course there has to be more reliable system for the critical loads. Now, how this uh, microgrid microgrid will be connected to the grid. Obviously, there are the circuit breakers, and then this circuit breaker, obviously, as you know, it is not like a simple switch, but it is more than the switch. Okay. So, as you know, as electrical engineer, that circuit breaker is not like the simple switch. As you can see here, this MCB, miniature circuit breaker. So again, you can have the minimum operation it as the switch on and off, but it has got the function more than that. It has got the more protection capability. If there is fault current, this MCB will trip automatically. Okay, so it has got the additional function. Same way, the circuit breaker, when we are, when this electrical connection is disconnected, in that situation, obviously, there is sparking when this electrical connection is disconnected. So in that case, there is chance of fire. So what you have this mechanism, quenching media to stop the flow of the current. Okay, so it is more than the switch. In fact, as you see here, the term static switch. I recall I saw one PhD student about 10 years earlier. One of the faculty member did his PhD just on the static switch. So this static switch, when you are connecting your microgrid to the grid, or you are isolating this microgrid from the grid. Okay, so the time of operation is extremely important. I give you an example. For example, in this power system, we have got the backup in terms of diesel generator. Okay, in almost every important buildings, you will have the backup in terms of diesel generator. If the normal power supply goes, and then diesel generator should be operated. We can have the priority loads. For example, this TV transmission building. Okay, so there we cannot afford to have this power interruption even for a few seconds. Okay, so how much time the diesel generator should take to run the diesel generator when the power fails. Okay, so here we cannot depend upon the human being that the power has gone, and then some person will come and operate the diesel generator. It can take 5 minutes, 10 minutes for the person to operate. Sometimes person gone for taking tea, so it can be half an hour. So priority loads cannot wait for that time. Okay, so the system has to be, completely automatic, and it has to be very fast as possible, so no one just see any interruption. Sometimes you would have seen, when you are seeing this television, if the power fails, then you think that whether power went or your eye flicker. So it has to be very fast. Okay. Same way like in the hospitals, you cannot afford to have power interruption uh, even for a second time. Even we have the industrial process where we cannot afford to have the power failure for seconds. Okay. So that way this static switch is very important, so that this connecting or disconnecting of the microgrid is very prompt, and it has to be the name what we call it, the intelligent breaker, the circuit breaker or the static switch, where we will be connecting our system what we call as the microgrid, call as the name like the PCC, point of common coupling. So as needed, this microgrid can be connected to the grid, or it can be uh, taken out from the grid in the isolated. Now, when we are talking about the options, uh, what we talk about the microgrid architecture, what what can be the architecture for this microgrid? So again, we have got the electricity, what we call as the AC and DC. Even when the electricity started 100 years earlier, whether we go for DC or AC, finally we end up with the AC system. Now we are mostly generating, transmitting and distributing electricity, mainly AC. But now again we see that some type of uh, sources like these photovoltaic systems generate the DC. The battery we see are the DC source. Then again, the conversion from DC to AC. Again, if you have got any device, it has got its efficiency. Okay. So basically, how we can further classify this like this microgrid? It can be based on this AC, or it can be based on DC. So you cannot say both will be like the perfect. Both will have some pros and cons. So what could be an improved version? Maybe hybrid AC and DC, which can try to little bit better than AC and DC as well. And then in hybrid, in literature, you can find some further subclassifications, classification like the AC microgrid with some DC storage options, or it could be DC zonal microgrid localized, and then this this static transformer based microgrid. So you can find several options. So little bit to talk about this architecture for this AC microgrid. So here obviously you have got this uh, grid, and with this grid you will connect the microgrid, and of course where you are going to connect this is a point of common coupling. So basically the grid voltage maybe higher voltage, and whatever the microgrid you are going to connect, it can have the different voltage. So obviously you may have the transformer. Then of course, like the your breaker system in terms of like the uh, circuit breaker, okay, and then of course the static switch. Even if you have to, you know, switch power from these different circuits. So this static switch, it can be automatic, it can be very fast as well. I give you an example. For example, in hospital, just your system has to be very reliable. Okay, how you can make? You can get the power to the hospital from the two or three different feeders, two or three different sources. Right? If power fails from one source, then automatically this static switch can, you know, switch over to the another feeder automatically. So as power fails, as fast as possible, it can automatically switch over to the another feeder. So you have got this way, like the two or three different feeders, automatically it can switch, but obviously the switch will not be connected to the, like the two different feeders at the same time. It can cause the short circuit. Okay. So you have got the options for two, three different sources. In addition, you have got the backup in terms of diesel generators. But now, of course, we started talking about the what we call as the sustainable solutions. These diesel generators offer, you know, um, several issues. If you run the diesel generators several hours, the cost, maintenance cost, operation cost, noise, pollution, so many issues. Okay, so we started seeing some options in terms of like the sustainable solutions, in terms of like photovoltaic systems, battery storage systems. Of course, we can have diesel generators, but the smaller size diesel generators. So here you can see that these feeders, basically here in this AC microgrid, they are obviously this AC feeders in AC microgrid. Then here with these feeders, you will be connecting the micro sources generations, uh, wind system, photovoltaic system. Some type of generation will be AC, some types will be DC. They can have the different voltages. So you will need kind of the power electronic converter. For example, battery is DC. So when you are connecting with the grid, so you have say DC to AC converter. Uh, Same way you have got the photovoltaic system, so you have got the DC to AC converter. You have got the wind generator. When you are connecting with the grid, even both are AC, so it may directly be connected, but some cases these two voltages may have the different voltages. Okay. Or sometimes to improve the power quality, to reduce the harmonics. So we use like the back-to-back converter. Then of course we have got the load. So this is a kind of AC microgrid structure. So this AC microgrid uh, has like one or more AC buses, and any device connected to the microgrid by means of AC interface. The most of the DCs require DC to AC power electronic interfaces. Obviously, this microgrid is connected to the point of common coupling. Uh, so that whole microgrid can be a feeder from the distributed grid point of view. Talking about the DC microgrid, so here you can see that this bus bar or feeder is DC, and all the sources in terms of storage systems, generators, loads connected to this DC bus are finally DC. Okay. Again, here you are also using the power electronic converters as well. So here with this DC microgrid, then talking about the third option, what we have here, we can have both a combined, what we call as the hybrid AC DC microgrid. So in this case, like we can have our one main feeder which is AC, and then we can have a separate feeder for AC and DC. So in this separate feeder, basically, for example, if we have most of our AC load which will be connected to the AC microgrid. If you have got some of the DC load, then obviously we will connect to the DC feeder. So having this hybrid microgrid, maybe we can reduce the avoid the unnecessary conversion efficiency. So for example, if we have got some DC load, maybe it can be directly connected to the DC grid. So it can avoid the unnecessary conversion. So now again we have started seeing the option that rather than all the loads we have the AC, can we think some loads to be DC as well? Okay. Like whatever the electricity we are generating from the photovoltaic system, it is DC. Can this DC be directly used? Can we have partially load as the DC? So we can avoid unnecessarily these conversion losses. Okay. So DC loads can be directly connected to the DC feeder without the need of any power converter. So this microgrid can be suitable for installation with critical loads in combination with more robust loads as well. Then it gives you like some sub classifications like the AC microgrid with the DC storage systems options talking in the literature. I'm not going into that much of detail. DC zonal microgrid, or you can have this solid state transformer based microgrid given in the literature. So now talking about the little bit about the microgrid control. As you see that when we have this power system, for power system to operate efficiently, some of the electrical parameters have to be maintained and they should be within the acceptable value. Okay. So here, whether we have this main grid or microgrid, it will require the energy management, balance of the power, both real power and reactive power, and the, the power system parameters, particularly voltage and frequency, they have to be within the operational limits. So, when we are talking about the microgrid, so here in microgrid, basically the control aspect becomes more challenging as compared to conventional power system, because in the microgrid you have the generation which has got the uncertainty based on the weather condition. Okay, the load, as you know, is also changing. On load, we don't have any control. It is completely the mood of the customer. When they want to use the electricity, they are paying the electricity. So the way they like, they use the electricity. Even the lecture is over, they want to switch on or switch off, keep like that. They say we are paying the bill, so don't worry. So basically, like the customer, they say we are paying the bill. Okay, don't teach us more, so don't worry about that. We will use the electricity the way we like it. So we cannot tell much to the customer. We can little bit mentor, but not much. Okay. So basically here some of the functions should be within the limits, satisfactory operation limits, particularly when we are talking about the power, the active power and reactive power. There should be maintained balance between the active power generation and active power consumption. Same way, reactive power generation, reactive power consumption in the system, it should be balanced in the real time. Okay. The electricity is the most fresh commodity. Okay. We are generating and consuming in the real time. Forget about the short duration of time, the storage system. Whatever we are storing as compared to total capacity, it is very, very small. Okay. Electricity, what it is being consumed, what electricity you are seeing here. So what do you think it was generated yesterday? It is being generated now and being used in the same time. Even whatever fruits you might be consuming, you may think that they are very fresh, but they might be 1 month old or even more than that. Okay. So the food, you may see that it may not be very fresh, but electricity what we are consuming, it is most fresh commodity what we are using. Little bit storage you are talking, but other than that, like say electricity generation, active power and reactive power, so it has to be balanced. With little bit plus minus variation is within the limit acceptable, but there should not be much variation with the active power generation, real power generation, real power consumption, reactive power generation, reactive power consumption. If that is the case, then there will be some symptoms, side effects. Okay, the quality of supply will be affected. Okay, so the basic minimum needs what power system engineer has to ensure, that they have to maintain the power balance, active power, reactive power in real time 24/7 without any holiday. So it has to be maintained. So 365 days, no holiday at all, no Christmas holiday, no Diwali holiday, it has to be maintained throughout the year. Okay. So basically, if in case of any fault, if you want to disconnect the microgrid, or you have to reconnect the microgrid, the operation should be very smooth, and depending upon the load, how much load to be connected, disconnected to maintain the power balance. So a proper scheme has to be decided, as Professor Rao explained about the issue of the load shedding. So load shedding, it is not only our country. I previously worked in 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 Pretoria, the capital of South Africa, and you'll see that South Africa is the most developed country in the African continent. In Africa, very big continent, and in that South Africa is one of the most developed parts. Okay. So that country has also faced this severe consequences of the load shedding, because they have this, hydropower generation, mostly coal-based power generation. But in hydro, we have to, if there is less rain, so we cannot operate hydro much. So in that case, again there is huge load shedding. We have seen that every day 4 hours, 6 hours of the load shedding. Okay. So you can see that there could be many places, many countries where this type of problem can be there. So whatever situation is there, we have to maintain our power system, whatever the best possible way. Okay. So here you see that when we are having our this microgrid system, or even the main grid, when we are operating, doing the control. So this control process, it can be defined in several ways, what we call as the primary control, secondary control, tertiary control. In the literature, they can extend it further. Okay. So one, you can say primary control, like the coarse control. Then secondary control, you can have the little bit fine tune. Okay. Then one control you are doing for the technical requirement. Then in addition to technical, whatever way you are operating the power system, it should have broader aspect, that economical aspect. Okay. So this way you can have the few stages for the control. So here, as you see, that primary control, mainly in the power system, we want to maintain frequency and voltage within the limits. So this is the most important aspect, that voltage and frequency we have to maintain within the specified limits. And we have to, our controller has to be very fast to respond to this disturbance in the order of milliseconds. And of course, we have to maintain the power balance, active power balance between the generation and demand. And then of course, we use the power converters, as we are integrating renewables. So there can be two different modes of operation for this microgrid, this power electronic converters, what is called as the grid following and grid forming. Okay. So we will see little bit more in the another session. but here to briefly explain what you will see as this called as the grid forming, grid forming, and the grid uh, grid grid forming and grid following. Okay. So here you can see that this grid forming, as you will see that a source in series with the impedance. So it will appear like the, what you will see that Thevenin system. You recall circuit 1? Like as we draw this Thevenin circuit, a voltage source in series with the resistance or impedance. Here the another system being represented by a current source in parallel with the impedance. So appearing like the Norton circuit. Okay. So this way we have got the two different converter scheme. One is what we call as the grid forming, another is grid following. And then when we are talking about the primary control, we talk about the frequency control, the dupe characteristics, uh, employed in the converters, active load sharing. If you want to share the load between the different generators. So how we are going to do that? The voltage regulation, another one of the quality parameters. That voltage regulation we have to maintain within the specified limits. So that we have to follow. Same way, secondary control. So this works to compensate for the voltage and frequency errors. Will regulate the value of operational limitations for the microgrid. It ensures that voltage and frequency deviations are regulated to zero following each load and generation in the microgrid. And again, this control can be divided whether you have the centralized control or decentralized control. Then talking about this like the tertiary control. So here basically manage the power flow by regulating the voltage and frequency when the system is in the grid connected mode, and by ensuring that P/Q through point of common coupling, the grid active and reactive power can be compared against the desired reference. So, we talked about the microgrid control. We'll talk more about this microgrid control in the afternoon session as well. Then some of the like the microgrid examples. So this list is not the exhaustive. There can be many more. Okay. So microgrid, again you can further try to classify this microgrid as like the facility microgrid or remote microgrid. Remote, as the name indicates, in the remote areas, isolated microgrid. Or it could be a utility microgrid, and what particular applications you might be using for this commercial microgrid, or it could have some specific applications like the military applications in some university campus or some community microgrids. So this way microgrids can be uh, further classified. So, it little bit try to explain you the microgrid facility. Like the some examples, the giving the some country examples. Uh, what sort of mode it can have, islanded mode, how much the geographical area it can cover, microgrid. Remote microgrid, as the name indicates, it is only the isolated mode. It can supply power. Calculate the coal consumption for our country. Okay, so our country, the coal consumption or the electricity generation based on the coal, the electricity generation in our country is say around 250 gigawatt or 200 gigawatt. The power generation is this much. So you can make an estimate how much coal is being consumed on daily basis, how much coal will be consumed on yearly basis. Can you do this simple calculation? Yes or no? Is difficult or easy? No integral, no differential, simple, no scientific calculator, right? So you can get a feeling that how much coal will be burnt. Okay. Then, of course, when you are burning the coal, you have this coal burned, of course, with the air. Whether you electrical engineer studied or not, but mechanical engineer will study this in very much detail. When we are burning the fuel, we need the appropriate quantity of air. Air, fuel, appropriate quantity of air and fuel mix. Okay. If air is too much or air is less than the requirement, fuel consumption, fuel burning will not be proper one. Okay. So air and fuel have to be mixed in the appropriate proportionate. Whether you have this coal-based power plant or even you have got the any vehicle, your scooter or your car. So air and fuel mix, it has to be in the appropriate quantity. Okay. So the air quantity required is 10 times of that. Okay. Then of course you are burning this coal in the boiler, and this boiler has got the capacity 30 megawatt. How much is the, this is not very rough, just to give you very rough idea. It's not very detailed model. So around 10% of the power roughly takes as the exhaust gases. As Professor Rao mentioned about the diesel generator. So this 10% power is just waste as the exhaust gases. How these exhaust gases you are releasing in the atmosphere, whether you have some cleaning process, electrostatic precipitator or not. Okay. What height you are releasing this gas. Okay. So this bad effect, how much you can try to minimize. There is wastage of the energy. Then you are producing this steam. Whatever the steam we are going to produce, what is the temperature, what is the pressure condition of the steam. It is very important, because we are the mostly electrical engineer. You are electrical engineer, I am electrical engineer. Okay. So for us electrical engineers, for us only we will see about the voltage, about the frequency, maybe we can talk about the power factor, we can talk about the voltage regulation, we can talk about the harmonics, but we don't talk about the temperature and pressure. Sometimes we may not be aware of that what is the unit for the pressure. Okay. If you have a car, if you go to the petrol pump, if you ask the person to fill up the, air, so we cannot tell exactly how much to be filled up. What is the unit for that? There are so many units for the pressure. Pascal and what more? Units for the pressure. So you'll see that what I am trying to say, that being as the engineer at young stage you will be the engineer, later stage you become the manager. Okay. Then you cannot say that electrical is only my area. So you will be the in charge for the whole plant. So you need the bigger role. Okay. So after 10 years of your job, you cannot say that I will only take care for the electrical part. You may be required to take care for the mechanical. In power plant, there is nothing like the electrical engineer or mechanical engineer. Even civil engineer may be also doing the same job. So the engineer will be the power engineer. Any engineer in the power plant is the power engineer. So you need to be quite diversified. Why I am telling, I worked previously at BITS planning. I am not just reading from the slides, I have to tell little bit of my experience as well. If I am just talking through slide, you may get bored. Okay. So when I was at BITS planning, we used to have BS program for NTPC. I think everyone knows about NTPC, right? So NTPC, our utility, generating around 25% of electricity in our country, mostly through the coal-based and gas-based power plant. I visited almost all the power plants in NTPC, Delhi, Dadri, even up to Farakka. Okay, so I visited almost all power plants. So the point what I am trying to tell here, that you are producing the electricity, significant part of this energy is waste in the condensation process. How much water is required? How much water is required in the cooling? So you can say that 1 kg of coal, and here the water quantity required is 360 kg per second. So it means you will need the huge quantity of water. So obviously this coal-based power plant, nearby area there should be any river. Okay. In some cases, if there is no river, in exceptional cases you can use the sea water as well. I visited one power plant in the this Visakhapatnam. At that time, NTPC power plant was being constructed. I think that was the first plant that water was taken from the sea as well. You will see that it's not that great as well. You have to condition that water, but still, if there is no availability, you have to find some way to move forward. Okay. So you have this all these things. I was mentioning about the temperature, pressure, the steam being used in the power plant. It needs to have the appropriate quality, as we are talking the quality for the voltage, frequency. Here temperature, steam temperature around 550. So you as the engineer at least know what is the temperature for the steam. If you go for job interview, how much is the temperature? Someone say I don't know, but still someone asks you, please tell. Someone can say 100, 200. So all these answer incorrect. The temperature being used in the steam power plant around 550 degree. It could be 570, 580, but around 550. Then pressure. So here the point what I am trying to stress, think about the quantity, how much coal is being used in the power plant. and then you see when you are burning 1 kg of coal, sometime in the winter season, when too much winter, then we have small stuff where we are burning coal, right, to make the home heated, right. If it is not properly ventilated, in the night people's, sleep. Unfortunately, sometimes here that people were unconscious, right. So if you think that burning of like few kg of coal, how much consequences it can have when we are burning this huge amount of coal and we are just releasing in the atmosphere. So please everyone try to think, do some calculation. I will ask this question maybe at the end, like say 200 gigawatt plant, how much coal will be consumed, how much emission in terms of gases, CO2, SOx, NOx it will release, how much issues it will cause to the health. So this is extremely important, because when we know, then we can try to, tell or mentor other people. When we simply say the coal-based power plant is releasing some coal, we don't know how much coal is being consumed. Okay, I hope everyone followed this point. Okay, so basically, worldwide, like not a single country is now in fear of that. Of course, at the end, everyone needs the electricity. Everyone needs the electricity, whether we are polluting, whatever we are doing, but at the end, to run our life, because nowadays we cannot imagine our life without electricity. Okay. So this has become the minimum requirement. Okay. Roti, kapda, makan and electricity, right. Not only electricity, but electricity with Wi-Fi, right. So this has become the basic needs. Not only electricity, we can stay without electricity, but Wi-Fi should be there, right. If you don't get Wi-Fi few minutes, we become impatient. Okay. So Wi-Fi after this Wi-Fi will also be down if there is no electricity. Okay. So how much dependent we have become. Okay. Any type of electricity being consumed, we have to see how this electricity is being generated. So I just wanted to just start this morning session, and then we will continue. This slide, particularly this topic, is my most favorable topic for this all presentation. That's why I thought I will take little bit more time, give you little bit more broader aspects, so that really you can appreciate. As I said, like whatever renewables we are talking, it is not just related to microgrid, but as much renewables as you can get, whether small to small scale, micro, even Chinese people talk about the after micro, nano, pico generation, right. So any electricity you can generate, whatever smaller scale up to pico, and whatever bigger size you can go mega, then giga, what more, any scale you can go. So but we need the electricity which is sustainable and renewable, because what you are seeing from the coal, oil is a big concern. Okay. So with coal, like we cannot sustain, our environment cannot sustain further. we are seeing so many health issues. We commonly hear so many disease, so many issues like cancer. Previously, hardly we will hear any cases, but now these are getting so common. Do you agree? Okay. So directly, indirectly, one way we are saying that we are improving our quality of life, but same way, like say our health conditions, even being so comfort, but still the health, deteriorating. Okay. So I'll just stop, and then I think we have break for the lunch, and then we will, as per schedule, we will continue after the lunch.